5-6 is about factoring trinomials. A trinomial is 3 terms. So a squared plus 12 is 18a plus 81. Now, one solution, one way of factoring, these are called perfect square trinomials. These add up to a square of x plus b. Now, if you square x plus b, you get x squared plus 2bx plus b squared. Now, if you're starting with this, I want to factor it to this. Here's the trick. Here's this coefficient 2b. We divide it by 2, getting a b, which goes there. If after squaring it, you get the same thing, b squared, then this is the case. For example, to factor x squared plus 6x plus 9. Take half of 6, that's a 3. Square that, get a 9, and since it matches that, that means that this equals x plus 3, this 3, all squared. Now, if you had a minus 2bx in the denominator, well, much the same thing happens, only get a minus instead of a plus. Divide minus 2b by 2, you get negative b. Square that, you get the same b squared. If it matches that, then the whole thing equals x minus b, all squared. For example, x squared minus 10x plus 25. We take half of this negative 10, that's a negative 5. Square that, that's positive 5. It matches to that. Therefore, this trinomial equals x minus this 5 squared. So, for example, a squared plus 18a plus 81. What's that? Well, you can think of this as 18 is twice 9 times a, and 81 is 9 squared. So it's a squared plus twice 9 times a plus 9 squared. So, and that's going to be a plus 9 all squared. This is a little trickier. 4y squared plus 28y plus 49. Now, it's easy enough to recognize the 49 is a 7 squared. And the 4y squared is the square of 2y. Now, this middle term should be twice the product. 28y, let's see, is that twice 2y times 7? Yes, it is. So squared plus twice product plus square equals a sum, the square of the sum. So this will be 2y plus 7 all squared. Sometimes I lose track. Just a second. Wait. Let's make sure I got this right. Apologies. Sometimes I neglect to keep track of. Sometimes neglect to keep track of where I am in here. Let's see if this is the right spot. Here we go. Now here's something that I call the PQ method. You have x squared plus bx plus c. You can factor that into x plus p times x plus q if p and q add up to the middle coefficient b, and their product p times q is c. Now, it's easy enough to prove that. Just take this on the expression and expand it. X times x squared, that checks. Px plus qx, that has to be bx, therefore p plus q is b. And p times q, that has to be c. So you can factor this if we can find numbers p and q whose sum is b, the middle coefficient, and whose product is c, the final coefficient. To find it, one way is to search among the factors of c to see which ones sum up to b. For example, x squared plus 5x plus 6. Okay, their sum must be 5, their product must be 6. So whatever q is, it's 6 divided by p. So I'll try various values for p. Q is 6 over p. Find their sum. Okay, so let's do a search. If p is 1, then 6 over that is 6. 1 plus 6 is 7. Not quite. If p is 2, then 6 over p is 3. 2 plus 3 is 5. Yes, that works. So x squared plus 5x plus 6 equals x plus 2 times x plus 3. There. Okay. t squared plus 14t plus 48. Their product is 48. Their sum should be 14. So whatever p is, q is 48 over p, because their product's 48. And then we'll try values of p and find what p plus q is. If p is 1, then q is 48. And these add up to 49. Not quite. If p is q, then 48 over 2 is 24. 2 plus 24 is 26. Closer, but not quite. If p is 3, then 48 over 3 is 16. They sum to 19. We're getting warm. If p is 4, then 48 over 4 is 12. Their sum is 16. We're getting much warmer. If p is 6, then q is 48 over 6, which is 8. You sum to 14, which is exactly what was required. And so therefore, this equals t plus 6 times t plus 8. So here's y squared minus 17y plus 72. Again, we need two numbers, p and q, whose sum is negative 17 and whose product is 72. So we'll look for among the factors of 72. Whatever p is, q is 72 over p. And we see if the sum is the right thing, namely 17. Now, if we start with p equals 1, then q is 72, and their sum is 73, which is not only the wrong size, it's also the wrong sign. We want the sum to be negative. But that can be fixed. If p is negative 1, and q is negative 72, and p plus q is negative 73. Still the wrong size, but at least the right sign. Okay, instead of negative 1, let's try negative 2. 72 over negative 2 is negative 36. They sum to negative 38. Closer. If p is negative 4, then 72 over negative 4 is negative 18. Their sum is negative 22. We're getting warm. If p is negative 6, then 72 over negative 6 is negative 12. The sum is negative 18, a lot closer. And if p is negative 8, then 72 over negative 8 is negative 9. The sum is negative 17 as required. And therefore, this expression equals y minus 8 times y minus 9. Here. All right. Now, we've been factoring x squared plus bx plus c. Now, to factor ax squared plus bx plus c, it's a little more complicated. Well, it's a similar method called the AC method. Like before, we know to find a p and q. Their sum is still the middle term coefficient b, but now their product, pq, must be a times c. So then if you can find p and q whose sum is b and whose product is ac, then we rewrite ax squared plus bx plus c. We write this bx as px plus qx, because p plus q equals b. Now the idea is that this, when you split this into these two terms, these four terms will then factor by grouping, by unfoil. For example, 2x squared plus 5x plus 3. We need two numbers whose sum is 3, and whose product is 2 times 3, which is 6. Well, 2 and 3 work. 2 plus 3 is 5. 2 times 3 is 2 times 3. So we'll write this 5x as 2x plus 3x. Then we can factor these four terms by unfoil. 2x squared plus 2x is a common factor of 2x times factoring out x plus 1. 3x plus 3 is a common factor of 3 times x plus 1. 2x times x plus 1 plus 3 times x plus 1. So here's x plus 1 is a common factor. Out it comes, times 2x plus 3. There it is. Well, I hate it when I click off and I forget which one I clicked off from. Here is why the AC method works. The book doesn't go into it. I think it worth noting. So here we go. We have two numbers whose sum is b and whose product is a times c. Then q in particular is ac divided by p. That just follows directly from here. Then this, ax squared plus bx plus c. We'll write bx as px plus qx. We'll write qx as ac over px. Now, this will factor by unfoil. Ax squared plus bx, one more step. I'll write C as CP over P. Because we have a C over P here and here, you see. Now, okay, having gotten into this form, these first two terms have a common factor of x times ax plus p, like that. These two terms have a common factor of c divided by p times ax plus p again. Well, what do you know? Ax plus p is a common factor. Out it comes. Times x plus c over p right there. So this works, this AC method will work in general. So let's do some examples. Oh, and by the way, y, every time the answer is every time we factor an expression, we can solve a corresponding equation. So for example, let's factor 5x squared plus 13x plus 6. We need two numbers whose sum is the middle term coefficient 13, and whose product is 5 times 6, that's 30. Sum is 13, product is 30. All right, so we have P, Q is 30 over P, and let's look for the sum. If P is 1, then Q is 30, and the sum is 31, too big. If P is Q, then is 2, then Q is 15. The sum is 17. Well, it's closer, but not quite there. If P is 3, then Q is 10. And 3 plus 10 is 13, as required. So there we go. So the next step is to write this by breaking up this 13x into 3x plus 10x. So 5x squared plus 13x plus 6 is 5x squared plus 3x plus 10x plus 6, having broken up the 13. Now this will unfoil these two terms and these two terms. 5x squared plus 3x is a common factor of x, leaving behind 5x plus 3. 10x plus 6 is a common factor of 2, leaving behind 5x plus 3. Well, there's a common 5x plus 3, pull it out, times x plus 2. And this is the factorization. Here's 7a squared plus 12a plus 5 is what? Well, okay, we need two numbers whose sum is 12, the middle term, middle coefficient, whose product is AC, 7 times 5, which is 35. Well, okay, it should be fairly obvious that 7 and 5 work. Their sum is 12, their product's 35, so that works. So I'll write this 12a as 7a plus 5a right here. So we get 7a squared plus 7a plus 5a plus 5. This should unfoil. The first two terms are 7a squared plus 7a, which has a common factor of 7a times, after you divide, times an a plus 1. 5a plus 5 has a common factor of 5 times an a plus 1. These a plus 1s are in common, so we pull them out, and we're left with 7a plus 5. Here we have 7g squared minus 12gx minus 4u squared. What's that? Well, okay, here we go. Their P and Q must sum to negative 12. Their product must be 7 times negative 4, which is negative 28. So whatever P is, Q is negative 28 over P, and we look for the right sum. If P is 1, then Q is negative 28. The sum is negative 27. Not right. If P is 2, then Q is negative 14, and the sum is negative 12 as required. So we'll write this 12gh as 2gh minus 14gh right here. 7g squared plus 2gh minus 14gh minus 4h squared. These first two terms are 7g squared minus 2gh, common factor of g, times 7g plus 2h. There's a minus 14gh minus 4h squared. And, well, okay, you can pull out a 2h, but let's pull out a negative 2h just to make sure that the signs match up. Pull out a negative 2h times, again, 7g plus 2h. Okay, 7g plus 2h in common, pull it out. 7g plus 2h times g minus 2h. That's the factorization. Now this one, it's sort of a mess because it's 6th power. 64h to the 6th, 24h to the 5th, minus 4h to the 4th. And what's more, 64, 24, and 4 are common factors. Well, okay. First, we'll pull out common factors. 64, 24, and 4 have a common factor of 4. Here's h to the 6, h to 5, h to 4. They have a common factor of h to the 4th. So we remove 4h squared, and we divide these terms by that. You're left with times 16h squared plus 6h minus 1. Now, all right, AC method shows up. We need two numbers p and q whose sum is this middle coefficient 6, and its product is 16 times -1, which is -16. So whatever p is, q is -16 over p, and we look for the right sum. P is 1, and q is -16. The sum is -15. Wrong sign, because this is positive and this is negative. So we flip it. If p is -1, then q is positive 16, and the sum is positive 15. Well, it's the right sign, but the wrong size. We proceed. If q is -2, then if p is -2, then q is -16 over -2, which is an 8. If we add these up, you get 6 as required. So there we go. So from here, we're going to write this 6h as minus 2h plus 8h, minus 2h plus 8h from 6h. 4h to the 4th times 16h squared minus 2h plus 8h minus 1. All right, let's factor this by grouping. 6h squared minus 2h is a common factor of 2h. Divide each of these terms by 2h, you get 8h minus 1. Here we already have an 8h minus 1, so we have it all multiplied by 1. Okay. Now we can pull out the 8h minus 1. Here it is. We bring down the 4h to the 4th, which we shouldn't forget along the way. And what we're left with is 2h plus 1 here. So 4h to the 4th times 2h plus 1 times 8h minus 1. Five x to the 4th plus 4x plus 1. We need two numbers whose sum is 4 and whose product is 5 times 1, which is 5. All right, whatever p is, q is 5 over p, and let's look for the sum. Ooh, problem. If p is 1, q is 5, sum is 6, which isn't 4. The only other factor of 5 is 5, and then 5 over 5 is 1, and again the sum is 6, which isn't 4, so we cannot factorize this. At least we can't factorize it in integers. So this is what's called a prime polynomial. Here there's a little bit of trickiness. 12y to the 6th plus 23y cubed plus 10. Now, this is terrible looking because it has a 6th power. But really, the 6th power is the square of a y cubed. So it's really a quadratic in disguise. Okay, to factor this, we need two numbers p and q whose sum is the middle coefficient, 23, and whose product is 12 times 10, which is 120. So whatever p is, q is 120 over p, and we look for p plus q. Now, okay, I have to go through a bunch of possibilities. 1, 120, 121, no. 2, 60, 62, no. 3, 40, 43, no. 4, 30, 34, no. 5, 24, 29, no, but it's getting close. 6, 120 over 6 is 20, plus the 6 is 26, not quite. If p is 8, then 120 over p is 15, and these do indeed add up to 23. So that's what's required. So I'm going to write this 23y cubed as 8y cubed plus 15y cubed, like here. So this expression equals 12y to the 6th plus 8y cubed plus 15y cubed plus 10. This we can factor by grouping. 12y to the 6th plus 8y to the 3rd, they have a common factor of 4y to the 3rd. Divide this by 4y third, you get 3y cubed. Divide this by 4y cubed, you get 2. 4y cubed times 3y cubed plus 2. Here we have a 15y cubed plus 10. common factors of 5, and 2 times 3y cubed plus 2. Okay, 3y cubed plus 2 is in common, pull it out. That times 4y cubed plus 5 right here. So it's factors to 4y cubed plus 5 times 3y cubed plus 2. All right. Here's a rather terrible looking one with an 8th power, but that's really just the 4th power squared. Now let's see, 28m to the 8th minus 60m to the 4th n plus 36n squared. Now 36n squared is the square of 6n. As 25m to the 8th is the square of 5m to the 4th. Now, if we can write this as minus twice the product of these two, we'll be okay. Well, let's see, minus 2 times 5m squared to the 4th times 6n. That does indeed multiply out to minus 60m to the 4th n. So you have a square minus twice the product plus a square. That equals the square of a difference. So 5m to the 4th minus 6n, all squared, solves the problem. Let's see. Oh, wait, to make sure. Oh, wait a minute, did I do everything? Just make sure. Did we complete the section? 5, 6, number 9. App. Yes, we're done. So let's stop recording.